Test-Rig webinar part 2. I am Anjum Parvais. I'm Global Sales Manager. And together with me is also Murali, who is our Product and Support Manager. Murali is not standing here beside me. He's at his remote desk because he will be going through the online user interface with you in a moment. This is the second Test-Rig webinar, and we will show you how to use the Test-Rig. We are again here in the Mouldflo factory area. This is the Test-Rig. It's powered on. We have filled the Test-Rig with water, and the Test-Rig is connected to a mould. It's a mould with 4 channels, but in this webinar, we will use 2 of them. As explained in the first webinar, the Test-Rig is designed with the purpose to check and verify if a mould's cooling channels are performing according to calculation and design. The purpose of the Test-Rig is to check if the mould cooling channels are damaged or blocked because of rust and scale, etc. And also with this Test-Rig, it is possible to do an extended test, which can where you can find the optimal flow rate by applying the minimum water pressure. Today we will we will talk about the Test-Rig and the Test-Rig user interface and the software. And the agenda point is that we will walk you through the menu. We will walk you through the setup and configuration of the Test-Rig. We will show you how to configure the mould and how to prepare for the tests. And then we will do 3 tests. First, we will do the flow test. Second, we will do the pressure test of the cooling channels, both with 2 mediums. One is with air and the other is with water. And then we will do the extended flow test at the last. Then we will wrap up, and we will clean the hoses for water and clean up after the testing, and then we will purge the water from the Test-Rig. We will also show you how to share all these test results either on a USB or through Wi-Fi and Ethernet to your local area network. Lastly, we will also show you how it is possible to connect this Test-Rig setup with our help desk center in Denmark, so that we can provide you with training and also service and support. We will end this webinar with a Q&A session where the word is free. Everybody can ask questions, and then we will try to answer them as best as possible. So I think let's begin. Murali, would you please kindly walk us through the menus of the Test-Rig?
Thanks a lot, Anjum. I'll just share my screen.
I will just turn my screen so I can see it as well, so I can follow what Murali is doing.
As you can see, this is the main screen of the Test-Rig, and this is actually the measurement screen where we see all the flow and the pressure measurements for the Test-Rig. So if you look at the bottom right corner of the screen, you can see 4 icons, and the leftmost icon, which I'm hovering my mouse across, is the main screen wherein you see the flow and pressure parameters of your mold while testing. So this is the main screen that gives you a main overview of all the 4 flow cooling channels and the pressure, both the inlet pressure and the outlet pressure at the mold while doing testing. And if you click on the icon besides the main dashboard icon, which is the wedge icon, so here is the configuration screen of the Test-Rig, wherein you can do troubleshooting, you can know the status of the system, and you can set up some configuration items on the Test-Rig based on your requirements. So to start from the leftmost, so on the left top, you can see the water reservoir control, wherein it shows the level of water within the tank in the Test-Rig. And here we have sufficient water in the Test-Rig, and that's why it says tank is okay. And if there is no water, then it will prompt to fill up water in the test rig. So besides that is the flow reference test, which I will come to later. And below that we have the status of the pump and the valves, which we can do for just running the test rig to do some test scenarios, or just doing some test cases and checking out whether all the pump works and whether all the valves work. So these are the different controls you have to test the pump, also to test the valves. So we have three valves here, which is one for water and two for compressed air, which we use for all our test cases. So should something you think something is not working during test, so you can come back to the screen and then play around these valves and the pump to see whether all are working as it should. And then if not, then you can, yeah, of course, get back to us and then we'll help you with how to resolve this. If you go to the right side of the screen on the top, you can see the system status, wherein we provide you a basic overview of different components of the test rig and whether they are okay or not okay, ready, online or offline. So if any of these items were not okay or not ready or not online, then we have some issues with some of the components of the test rig. So here you can see the status of the different components that goes onto the test rig. And below that is the configuration that the test rig comes pre-configured from factory and is delivered to you. So based on your requirement, we pre-configure it, and more often than not, uh, in rare cases, you can reconfigure it, but it is best left untouched. Here we can change the sensor types, the password, the location, and some parameters with flow and pressure tests. I will basically touch upon what these parameters mean, and then in subsequent sessions, if we have more queries on that, we can take it up either later in the session or in subsequent seminars. So I would like to touch upon what the flow stabilization timeout is. A flow stabilization timeout is nothing but the timeout we set at the software to ensure that the flow across all channels are stable enough to make a measurement. And we wait for a period of 60 seconds for the flow to get stable, meaning the variance across flows in a flow tubes are equivalent to zero. And if we cannot achieve a stable flow within 60 seconds from a software point of view, then we just time out and then make the measurement. So that's what we mean by flow stabilization timeout. And the flow stabilization limit is in flows, and it shows the variance of flow across channels should be close to zero. That's why we have set a point of 0.020, which is close to zero. And if the flow across channels were to reach this difference across channels, then we take a measurement, meaning that the flow becomes stable when the variance across channels is close to zero. And the same with the pressure stabilization duration, wherein we, after pumping a particular bar of pressure within the system, we let the system be as is for 120 seconds or how often you want it to be as is. And the basic idea is to make sure that the system is stable enough after making some changes on the system. So when we put some kind of a pressure inside the system, we ensure that the system should take some time to react to the change, meaning react to the increase in pressure in the system and then stabilize itself. So we normally recommend a stabilization duration of somewhere between 2 to 4 minutes. So it's up to you and your requirements. How do you want it to be? But we normally recommend anywhere between 2 to 4 minutes. So we do a stabilization of a system and then we take a measurement. And then the last parameter is the maximum pressure loss. And this is the acceptable pressure loss you like to have in your mold. So it is by default zero point 0.1, in certain cases 0.06. So it is also subjective to your individual use cases and requirements. So this is the basic overview of the configuration and the status screen, wherein we see the configuration items of the test rig, the status of different valves, pumps, and the water reservoir. And please bear in mind, I'll come back to the flow reference test during the test procedure that we do and why we need to do a flow reference test. But just be aware that we need to do a flow reference test every time you use the test rig to have an updated flow, you can call it calibration or a reference point for all flow channels within the rig so that we can use it for the extended flow test. So it's kind of taking a ballpark flow readings when the test rig is open and it is connected with all hoses and fittings, but without the mold being connected. Here we measure the resistance of our equipment before the mold is connected so that we can, at all situations and circumstances, give the accurate readings possible and use this data for using extended flow test that we'll be covering later in this session today.
Super, Murli. I have a couple of questions, if it's okay.
Yes.
So what you mentioned regarding the test rig flow reference, you say that this is something that we refer and we recommend that should be taken on a regular basis. And what you mentioned is that it's basically if somebody banged the rig, for example, or hit it very hard, then all the components and this test rig system can be out of sync, you can say. And so by doing this reference test, it's like we create a 0 point, you can say, upon which the test then will be taking.
Yes, that's true. Because the basic idea is like, say, you do a couple of tests, you use the test rig for a period for 1 or 2 months, and you have some scale buildup on the manifolds, and then that will bring in some error coefficient into your flow readings. So you want to make sure that we factor in these error coefficients and make sure that when making the test, we apply these error coefficients and give you as accurate readings as possible. So
Okay.
that's the reason we recommend to do tests every time you use a test rig. Maybe you use it once a month, couple of times a week, or once in 2 months, no matter whatever the use case is. Every time you use a test rig, we recommend to have an updated flow reference measurement so that we can calculate and save these error coefficients should there be any.
So, but what if you do a test, use the test rig every 2 or 3 hours in a day? If you do it 4 to 5 times in a day?
Yes, that's why we have a recommendation of doing it at a bare minimum of once a week if you do it
Okay.
frequently.
So it's more like if you have not used the test rig for a while, then it's a good idea to first perform this one.
That would be correct.
Okay, super. Thank you. I have another question regarding the lower left corner. You mentioned about the flow stabilization limit, the 0.02. What is the unit of it?
It is in liters.
So it's liter per minute.
Yes.
Yeah, liter. Perfect. And when we talk about the flow stabilization timeout and the pressure stabilization duration, this is the time that the test rig will be doing these stabilization before the actual test starts up, correct?
That would be correct. The basic idea being, so that's a system, and you, you kind of make a reaction on a system. So the idea is the system takes some time to adjust to that reaction,
Yes.
meaning a reaction of doing a flow test or subjecting system to a pressure. So the system needs some time to readjust itself and then come back to equilibrium before we make a measurement. So that is the basic idea of having a stabilization period or a stabilization timeout for all these flow and pressure tests. Because in any system which is in equilibrium to begin with, if you apply a change on the system by a flow or a pressure, then we have to wait for some time before the system were to adapt to that change and come back to equilibrium before making a measurement.
Make absolute sense. It makes the measurements more accurate.
Yes.
So the limits that we have on the stabilization and also the pressure loss, these are the values that we put in, and if it exceeds these, then the tests that we will do later will not pass.
Yes, that is true for yes, that is precisely true because if the flow is not stable enough, then maybe the test fails. So it is always important that the flow for flow test, for example, the flow variance is near equal zero, and for pressure test, we don't have a pressure loss of greater than zero point 0.1 bars. So
Okay.
that is very, very crucial here. So if you were to say that if pressure loss of close to zero point 0.5 bars is okay for my requirement, then you can do that too.
Okay. Super. Thank you.
Yes, and then this is the basics about the configuration screen and the system status screen, wherein you can configure the different options for the test rig and also do some troubleshooting for the pumps and the valves and get to know the status of your tanks and also do a flow reference test to get a benchmark of flow and error coefficients of the test rig updated all times. So you can see an icon next to the wrench icon, which is the test icon or the notepad icon. And this is the testing screen wherein we do all the different types of tests like flow test, pressure test with air, pressure test with water, and extended flow test. We'll come back to this screen a little later. And then further down, you see a gear icon. And if you click on the gear icon, this is the main screen or this is the starting point wherein you create a mold. And this is a starting point for the software. And this is the first step in the workflow that we recommend you to do is to create a mold before doing any test. So assume that you have connected a mold which has two channels onto the test rig. The test rig is filled with water and you have connected the mold which has two channels. And now we have to configure that mold in our software and then test the mold in our software. So the first step that we do from our software is to create a mold, which is a virtual abstraction of the physical entity which is actually connected with the test rig. So what we do, we just first, before creating a mold, we just click on the default button to load the default settings, and then we give a mold a name, test mold, as a name of the mold. And I know my mold has two channels, so I enable two channels, and I'll just say give my comments for that mold. What is my use case for that mold? For test purpose, for production QA validation, or whatever is appropriate for you to feed that in. And here to the bottom, you can feed in the pressure set point that you know the mold to operate in. So for example, here I know that my mold has optimal flow at 1 point bars of delta pressure, which is the pressure inlet minus the pressure outlet. But in other situations wherein you don't know this value, you can just start the pump and then see what the flow is, and then you can just raise it and lower it up to 4 bars of delta P to see how much of flow you want to get or how much of flow you ideally must have, and then use that delta P and then save it. So here, since I know my ideal pressure set point for my mold, I just set it at 1.5 bars and then I just save this mold. And when I click on save, it prompts for the password, and then I just give my password 1234 to save this mold. So that's done. This is the first step. The first step is to create a mold configuration which verbatim reflects the physical mold that you have, the number of channels you have in the mold, the pressure or the differential pressure the mold is configured to run at, and any appropriate comments for that particular mold, and then saving the mold. So now you have created the mold in the software. The next step after creating the mold is to go and click on the notepad icon, which is the testing screen, where you like to test the mold, perform some tests on the mold like flow and pressure tests. In order to do that, I just click on the load button, and then I can find the newly created mold, which is the test mold. I select that, I click on open, and then it shows me that this mold has two channels, channel 1 and channel 2. And here I can just feed in the name of the person who's doing the test, which is me, and then click on OK. When I click on OK, it just opens into a template wherein I have a Mouldflo logo on top and the mold configuration at the bottom. And I also have a measurement history, which is right now doesn't have any values, and the final comments and the final approval signature. So as and when I do the test, you will see all these tests are populated under measurement history. So I have the most recent test on the top and the most dated test at the bottom. So you have a cumulative report of all the tests that you do for that particular mode in this report, and then you can just print it out and then share it and then file it for documentation purposes, sign it off, and do all the workflow requirements that you may have in your factory. So now that the mold has been loaded, now the next step is to do some test. So now let us start with the flow test. So to start with the flow test, I just click on the flow test button. A dialog pops up. It just shows that I have two channels to monitor. It tells me the mold ID, the date I'm doing the testing, the person who's doing the testing, and the location. So I just need to click on the test button. When I click on the test button, it sets the pressure up to 1.5 bars of delta P, which is the pressure I have given while creating the mold. So if you go to the main dashboard screen here, you can see 1.5 bars of pressure, and it's a delta pressure, it's an inlet minus outlet pressure. And you can see 6.4 liters of flow in channel 1 and 2.2 liters of flow in channel 2. Maybe in this case that is okay for me because channel 2 has smaller diameter or something else. So it is subjective to your requirement, and if you feel it's not okay, then it's a fail, right? But in this case it's okay for me, so that's what I require. So it's measuring that. It measures a mean flow across channel 1 where the variance is close to 0, and a mean flow for channel 2 and the variance is 0. And since it's between 0 and 40 liters, which is the limit I have set while creating a mold, the test is okay. So it depends on what are the limits that you set while creating a mold and how you define the mold in the first place and how much maximum flow you expect during these tests across each channels. So in this use case, I'm okay with 6 liters of flow in channel 1 and 2 liters of flow in channel 2. And since I'm okay with that, I just click on save. The flow test is complete. And then when I scroll down, under the measurement history, I get a tabular column of the flow results, the date and time I did the flow, the person who is doing the test, the location, and the delta pressure of the flow test. So the use case is similar for all other tests. So no matter what test you do, all the later tests will be on the top of the measurement log, and all the data tests will be at the bottom.
So, Murli, if I can just ask, so that means that we have a mold that is connected, and we have connected two of the cooling channels, and we have performed a flow test onto these two cooling channels. And we see that in one of them, with a nominal pressure of 1.5 bar, it shows that there is approximately 6 liter in one of the channels and 2 liter in the other channel.
Yes.
So this is just how these are the facts.
Yes.
And then we can discuss about whether that other channel which have a lower flow, is that smaller compared to the other one, or is there something wrong in this channel because of blockages and so on?
Exactly. Because without the flow test, we can just assume because the mold is a black box without our test. But now we have run a flow through the mold. Now we know what the actual flow is in each of these channels, and whether it satisfies our requirements of the optimal flow that we have or we are expected to have for each channel. So
at
in
that
this case,
pressure.
yeah, at that particular pressure. So in this case, we have a variation between channel 1 and 2. And if that variation is okay as per the requirement, then it is okay. If it is not okay, then we tell them that something wrong with channel 2 and we have to do some maintenance activity on the mold circuits for channel 2.
Super, super. And also, when the test shows that it's passed, is okay, it is referring to the limits that we set in the beginning. That the 0.02, that if it differs from that.
Yes, that's true. So let me go back to the manifold configuration screen. So in the configuration screen, when you first create a mode, we set a lower limit and a upper limit. So here we have just set the lower limit to be 0 and the upper limit to be 40. So this can be configured. So what values you put that in, if the flow were to deviate or to cross those values, then that flow is not okay for you.
Exactly.
So this is very important when you create a mold, that we create the appropriate limits that we expect for the flow circuits within the mold.
And in this case, these upper and lower limits are according to the maximum level of the sensor
Yes,
measurement points.
that's by default. But you can always customize that. Perfect. Now now that we are done the flow test, let's do the pressure test with air and the pressure test with water.
And just before you start, so with the pressure test, we are now testing the integrity of the cooling channels.
Yes, that's true. So, and we also provide two options for that, one with compressed air and the other with water. And the reason for providing two options is that suppose that you have an older mold, which you are sure is might have some leaks, but you don't want to, yeah, create a flow wherein the water spills all over should something go wrong with the test and there are large leaks. In that case, we recommend doing an air test first, because if a leak is indeed there within the mold, then it is just compressed air which is just comes out. So you have a clean working room environment at all times. And if you're sure that the compressed air test passes, then we can go ahead with the water-based pressure test, which of course depicts the real world situation and the environment because of the viscosity of air and water. But this is just an option that we give you to have a clean room environment should you have any doubt with regards to the integrity of the mold that you are testing. So the workflow is the same for both air and water test. So whatever workflow I show for air test, it's the same for water-based pressure test too. The only difference being we are testing with compressed air, whereas we are testing with compressed water. That's the only difference. So let's start the test with the compressed air pressure test. So I just click on the compressed air pressure test button. And then here it just says that it just reminds me that I should have the compressed air inlet plugged in onto the test rig. So
And
if I,
I
yeah,
can just check from the side here, and I can see that it's plugged in.
perfect. Now we have checked that, just click on OK, and now we are ready to do the test. The workflow is the same as the flow test. The first thing you do is click on the test button here, and what it will do is that first it will start the process and it will fill in compressed air to empty the system out of any residual water that might have left behind if we had done any prior water-based test. So the first thing is to push compressed air into the system to empty any residual water from the system. That's the first step. Now the second step is to fill the compressed air up to 1 bar. So you can see here it fills approx to 1 bar. And then the third step, once the filling process is over, is to stabilize it for 120 seconds. So you have a timer running here, and then you will stabilize the system for 120 seconds, and that is up to your requirement. We recommend anywhere between 2 to 4 minutes. And then here we let the system be as is, and then let the system respond to the changes to the system, and then yeah, let us hope that it comes back to equilibrium. But here with compressed air, because of the properties of compressed air, there's no loss of uh, pressure because of the properties of compressed air, because there is no there's no pressure loss when the compressed air grows from a diameter of a smaller length to a diameter of a larger length and vice versa.
So Murli, this 2 minutes is our recommendation and based on our experience. But this can be configurable, so you can lower it and increase it. Is that correct?
That would be correct. It's based on one's requirements.
Yeah.
But this is our recommendation out of the factory. And please be aware that there'll be a question wherein they say, why not 2 bars, why not 3 bars of compressed air? And compressed air is highly explosive. So in order to maintain a safe environment at all times, it's always recommended to do testing of compressed air not more than 1 bar. So,
Hmm.
so to be safe and not to have any untoward incidents while testing and to have a safe environment while testing. So that's why we keep the compressed air to up to 1 bar. So
Yeah.
you don't need to worry about having a regulator. So if your factory compressed air is 6 bars, we have a regulator within the test rig that will, yeah, down convert it to 1 bar, or near about 1 bar, so that you don't need to worry about connecting a hose of, yeah, compressed air greater than 1 bar, like 5 bars, 7 bars. It will automatically use only 1 bar.
So
So now you can see here, now the 120 seconds has run over, and now is the measuring phase. And the measuring phase, we measure for consistencies for up to 60 seconds. And note down if there are any pressure drops that are happening within the 60 seconds. So any pressure drop that were to happen after the stabilization period is over and through the entire 60 seconds of the measurement period, we factor that in to our results. So if there is no pressure loss between the 60 seconds of the measurement period, then there's no pressure loss at all.
exactly. So right now, it's the pressure test is being commenced
Yes. And
and
now,
finalized now.
yes, and now the total pressure loss is not there, is zero, because, yeah, the accommodated pressure loss is zero point 0.1 bar, which is not there, and then it's a pass. So we just save the results, and then we can see, and as you can see in the measurement log, you can see the updated results of the air pressure test, the date and time of when we did the air pressure test, and whether the test was okay or not okay. And the similar workflow with the pressure test with water. So now I'm doing a pressure test with water, but with water, it is a safe environment to do pressure test of up to 7 bars too with water. Water is not an issue. So right now we are doing a compressed water test with up to 4 bars of delta pressure. The process is the same. The first phase is filling the test rig with water if water is not there already. So that we call it as a filling phase, wherein we first start filling the test rig with water so that the water circulates through the system. So now the water is inside the system. We close the return valve and pressurize the system. So now we close the return valves, all the valves that are connected to the test rig, to make it as a closed system, and then now we pressurize the system to about 4 bars, near to 4 bars. You can see here on the top, the pressure is ramping up, and it'll be nearly 4 bars.
So only this 4 bar, is that a factory setting?
That's a factory setting, and since we have a pump that can run up to 4 bars of differential shutter pressure, that's the maximum pressure that we use. So it's near about 4 bars, 3.98. Now we start stabilizing the system for the same 120 seconds and then do a measurement afterwards. So whatever pressure drop, now you see 3.94 bars. So whatever pressure drop that happens during this stabilization period of 120 seconds, we don't factor in our measurements.
Hmm.
Because the thing is, for compressed water, if compressed water flows from a diameter of a hose from a lower diameter to a hose from a higher diameter and vice versa, there's some pressure loss. And of course, the hoses would enlarge and stuff like that. So there's some factored pressure loss.
Hmm.
That's why we give a stabilization period. And whatever pressure loss that has occurred within the stabilization period, we don't use it for measurement. So now you can see close to a minute has run over in the stabilization period, and you can see close to yeah, 0.8 bars. We are lost that, so that we don't factor in during the measurement.
Hmm.
So this is kind of a real world test, if you can call it that, to simulate the integrity of mold by running compressed water into the mold.
But it's a kind of ensuring that you have the whatever test result that you're making, they are really accurate down to the digit.
Yes, we try to make it as accurate as possible. But here the pressure test, the use case as we see it is to check the integrity of the mold, and to to always like have a certification stating that the mold is ready to use. It doesn't have any leaks, so it's always in a peak working condition. That's why we do integrated test with the mold.
Exactly. Yeah. And now we can see that the actual test is now undergoing.
Yes. So now any pressure loss that were to happen in the measurement phase, we just captured that pressure loss. So the system is fairly stable now.
Hmm.
And then the pressure test has passed because there's no pressure loss. So we just save it and then release the pressure. You can see a little thud, which means that we have released the pressure out of the system. And we can also see the latest test results, the water-based pressure test with the necessary results. So the idea is the same and the workflow is the same for both water-based and air-based pressure test. The final test is the extended flow test. We call it an extended flow test because it just runs the flow at different pressure set points starting from zero point 0.2 bars right up to close to 2 to 3 bars, and we determine the optimal pressure set point that that you can get the maximum flow for. So this is kind of an optimization analysis for your mold, and to have a ballpark understanding of what is the optimal pressure set point that you can run your mold to get the maximum flow. So just for the sake of assumption, just say that you're running the mold at 4 bars and you're getting 10 liters of flow. This test will just show you maybe it's okay to run your mold at not 4 bars but 3.5 or 3 bars to give the same optimal flow that you mandate. So you can just save zero point 0.5 bars of energy during production, and you can translate that into, yeah, savings in energies. So that's what we tell you with this. It's just a graphical notation with pressure on the X and flow on the Y, telling you the optimal pressure set point wherein you get the maximum flow. So
Out of these cooling channels in this mold.
yes, in other words, it's like what is the least pressure you can apply to get the maximum flow.
Exactly.
So the procedure is the same. You just click on test, and then it will run the pressure test starting from zero point 0.2 bars, and we'll keep on running these tests for 10 samples right up to 2 or 3 bars based on the flow of water. So we'll do 10 uh, measurements, and then we'll capture that results, and then we'll tabulate into a graphical format wherein we'll give you a ballpark figure of flow and
Mm.
pressure curve. So this is the latest stage. So if you're more interested in doing testing to show that your mold is in always in peak condition, and you want to always check your flow cooling, mold cooling channels to be as per requirements, then we recommend doing the flow test and the pressure test often, and using that for internal QA purposes. But if you are more interested in energy optimization and optimizing flow and saving energy, then we recommend using the extended flow test, which will give you the insights of how you can save energy by reducing the amount of delta P that you apply on the mold. So this is a one level higher if you are more interested in optimization in addition to validation.
And this curve, these curve points that we are measuring, we can see that if you have a 0.2 bar water pressure in channel 1, you have 2.43 liter running through the cooling channel,
Yeah.
but it is less than 2 liter in channel 2. So since the sensors that we are using in this manifold have a measuring range between 2 and 40, so it will say that it will not detect this lower than 2 liter per minute flow.
That's
Yeah. And the same goes for 0.4 bar, but we can see that because of a doubling of the pressure from 0.2 to 0.4, that there is approximately, there's an increase in cooling channel 1 in flow rate.
yeah. It is just a test scenario that we're showing you. That of course, yes, yeah.
And it's telling that in channel 2, which is quite interesting, cooling channel 2, that even up to 1.2 bar, you will have less than 2 liter per minute flow.
Yes, maybe that's not ideal. Maybe there's some blockages. Maybe it's not.
Exactly.
Yeah,
We need to check that cooling channel.
yeah, that's true. So you can see at 1.6 bars, you can see flows greater than 2 liters.
Exactly.
So yeah, so it's not as good. Maybe the cooling channel is not like as good as cooling channel one.
Mm.
So yeah, if it's that is your requirement, then that is pass, and if that's not your requirement, then you have to check it out.
In this mold that we are testing, it has 4 cooling channels, and all of the cooling channels are equally same size in diameter. So we can see that in cooling channel number 2, obviously there is some kind of a problem. There is a blockage, something, and so that needs further investigation.
Yes, you can say that because yeah, if all these channels are the same size, then of course there's definitely an issue with that. And while the test runs, we can also touch upon a little bit on yeah the Wi-Fi features of that. So this test rig comes equipped with a USB dongle so that you can connect it to your local Wi-Fi network. And as we touched upon, we can use the remote VNC to connect and then troubleshoot, and also use shared folders to share files within the same Wi-Fi network. So we can do the remote transfer of files as well as remote support using the Wi-Fi connection that
Hmm.
now comes standard with the test rig. We have two more data points to collect, and then we are done.
This extended flow test, this is the one that is available in the premium test rig.
That's true. Because in the premium, we can also do some optimization in addition to validation. And please bear in mind that the basic version doesn't have the water exchange feature. So the filling of the tank and the purging of water from the tank has to be done manually. We have a water exchange feature only in the standard and the premium versions of the district.
Hmm.
So we take 10 data points and then do some mathematical models on those data points and arrive at a graph, a flow pressure graph, wherein we tell you what your optimal delta P could be in a graphical format. And you can use that information to save energy as a start. So now the test is done, and then we click on save, and then you see two curves, one for each channel. The black curve is for channel 1, which has better flow, and the red curve is for channel 2, which doesn't have a good flow. And then you can create a curve.
And we can see the slopes of these curves are flattening it out.
Flattening out, yeah.
That means that as the pressure increases, but you don't get the same amount of, proportionally the same amount of water through the channels. And that means that you are, relatively speaking, applying more energy, but not getting the same amount of water through the channels.
That's correct. So that's what the optimization result tells you. And then you can just click on save. So you can just file it for further consumption, and then you have that in your report as well. So you can see the optimization report in the test as well. So these are the different tests that you can do. And once the test is done, you can just click on the purge thing to purge water away from the mold. So we can run it, but we recommend purging water one channel at a time, so that all the pressure is focused at one point rather than, yeah, 8 channels at the same time. So you can do 1 or 2 channels at a time so that you have concentrated compressed air. But we don't recommend using large amount of compressed air for purging water, because it might break the sensors too. So it's a balance on how much compressed air you need to blow to purge water. So that is the final step. Once you're done with the testing, you run this for, yeah, for a minute, 1 channel at a time, and then purge water of this system.
And now the hoses are clean for water, and also
Yes.
the manifold.
Yes, and once you're done, you want to save this, right? You can click on
Yes.
save, and then everything is saved in the log file. And then if you want to reload the same mold, you can just reload the mold, and then all the data is still back there.
Mm.
And then you can just continue with your test. You can just do another flow test, pressure test, whatnot. And if you want to print, you can just say that for this test passed, and click OK, and then it just, yeah, prints out a report, and then you can just sign it off.
Which is actually perfect, because that leads us to the next point, which
Yep.
is how to save it, as you mentioned here, and how
Yep.
to share it
Yep.
um, through the USB, because we showed in the first webinar that the Test-Rig has USB slots, so you
Yes.
can save these reports on the USB, take it with you, and share it to others. And you can also connect to the internet and then share this file through Wi-Fi or an Ethernet connection to the local area network.
That's true. So the way you do it is, just for an example, just for an example. So you have the files. So you go to documents. So just for example, you want to share this file, test report. You just copy it, go to the home, and that's a folder called Mouldflo share. You can just paste it. Now we have 2 reports here in Mouldflo share that you want to access in your laptop. So
And
let's,
this Mouldflo share is a file on the server, on the PC inside the test rig.
yes, it's a shared folder that it can be accessed by any computer, Windows PC, using Samba share. It's connected to the same network.
So that means that if we connect this to the local area network, the test rig, through the other USB dongle, which is the Wi-Fi dongle, then we can on a Windows PC. Is that correct?
Yes, we can because my test PC, which is a Windows PC now, we can access the data using my Windows PC. So what I will just stop sharing now, and then I will share my whole screen so that I can show you how we can get data.
So while you are finding it, it means that the test rig is connected to the local Wi-Fi network. You are too with your computer. It's
Yes,
a Windows PC, and then the test rig and your PC through the Mouldflo share file, you can exchange files to each other's computer.
yes, it is just the IP address of the test rig, and then there's a share called Samba share. We just type Samba share as standard and just click enter, and then we get the test mold data in our PC, and then we can just copy it and then, yeah, use it for our local consumption. So
Super.
this is the idea of yeah, sharing reports on the test rig. And we also have some videos for setting up Samba share on our computer. So this is how we set up share on the Windows 10 PC. So we have to install an app in a Windows 10 PC, which is Samba Share 1.0, and then we are done. And then we can just access any test rig within that is connected to the same Wi-Fi or the local area network, for that matter.
Okay, super. And that is also, is there also a guideline how the test rig can be connected through VNC or VPN
Yes,
connection, so that we can provide, you can say, help desk support
yes,
and training while connecting
yes.
to the test rig.
We have a YouTube channel, and then in the YouTube channel, we also have videos, as you can see here, to activate remote VNC support. So right now, I'm doing this demo using VNC. So we can turn on VNC with the test rig, and then I'm using a client VNC software on my PC. And if I can have the test rig's IP and I have VPN connection onto the local area network, then I could connect to the test rig from anywhere, any part of the world. So that is the that is pretty seamless with the test rig now. So yeah.
Super, Murli. Thank you so much for the walkthrough how to connect to the local Wi-Fi network.
So here we can just, once you have a Wi-Fi dongle connected, it'll just show the Wi-Fi networks in your factory. I can just select a Wi-Fi network, feed in the password for that Wi-Fi network, and then you can just, yeah, get connected. So it's
Okay,
pretty
super.
seamless. So like you do normally with your laptops. So you can just connect to any factory Wi-Fi network. And we also have Ethernet support. So if you like to have it a wired connection within the factory, you can also do that.
Just show how to clean up and empty the the tank and finalize the testing.
Yes. In order to clean up, so once you are done with all the tests and you are done and you say that, okay, I don't want the water to be there, I can just click on empty
Okay.
to empty the test rig. And then within, yeah, say 5-10 minutes, you will have an empty tank. And
Okay.
then if you
Perfect.
want to fill it back again, you can just click on fill, and then you can just, yeah. So
Okay.
just click on empty, and then you don't need to worry about yeah, burning the pump, because once the water level reaches a the lower level of the tank, then the pump automatically stops. That's a safety feature we have built in, so you don't need to worry about running the pump without water. So this
Super,
empty
Murli.
process will stop automatically.
Okay. And maybe also you can show that, for example, we used 120 seconds of stabilization period. Maybe that can be changed to 60 seconds.
Yes, so this, every time we change it, the software will restart because it will change the latest configuration. So we just change it to 60 seconds,
Yeah.
and then you will reload the software, and then you can see the stabilization to be 60 seconds. So now you can see, you can go to any test, and then the stabilization duration will be 60 seconds. Yes.
Hi guys,
So
this is Camille speaking from Mouldflo UK. Just a
hello,
quick
Camille.
question, Murali. How do you prepare the test rig for the test rig flow reference test or the flow reference measurement?
Yes. So the one thing that we should always keep in mind while doing a flow reference, if I just click on the flow reference, right, is to open all the ball valves to full on the test rig and then run the flow reference test. The important thing to keep in mind is not to connect any mold in the system. Just open the ball valves on the manifolds on the test rig to full and then run the test. That's it.
Okay, so the hoses should be disconnected from the
The
mold.
hoses, yeah, yes, the hoses to the mold should be disconnected. It is
And
just a closed loop that we run within the manifold that comes in the test rig.
great, thank you.
You're welcome. I just would like to say this is the end of the second webinar about the test rig. We hope that you have found it beneficial and valuable. And of course, you're most welcome to contact us if you have any questions. Some words from my side is that we can see that this test rig is a very valuable tool for molders and mold makers. It helps verify the true performance of the cooling channels in a mold, and it also helps extend the lifetime of the mold. It also helps to optimize the production with regards to quality and energy consumption. And it does that by providing a lot of insight and knowledge. And all these leads to a better control. We see and hear from our customers who have acquired this one that it is an indispensable tool for them. And it's regardless actually of the type of molder and the molding, the type of production of the plastic, whether it's medical, healthcare, optics, automotive, packaging, and so on. And it's also regardless of whether you are a very big molder who has a lot of making a critical component production and who automatically have a lot of requirements for validation and documentation and so on. So with these final words, I would like to say thank you very much to all of you and see you on next webinar.